All right, we're going to start working with monomials now. And one of the big jumps we're going to make now is instead of working with monomials or single terms that have numbers as their basis, we're going to be working with single terms that have variables as their basis. So when I look at this, x to the fifth, remember what that means is x times x times x 5 times. We talk about x as being the base and the 3 is the exponent. Sometimes we talk about 3 as being the power as well. So you'll see those words used interchangeably, so don't be fooled by them. Now, working with monomials, then how do we go back and how do we remember how to do these things? So I always go back to the meaning. What does it mean when I have x to the 5? Well, what that really means is I take x and I multiply it by itself 5 times. So I've got 5 x's multiplied together. Whereas when I have x squared, that really means 2 x's multiplied together. So when I count all that up, when I look at them all together, I don't have 5, but I actually have 7 x's multiplied together, and the short way of writing that is x to the 7th power, like that. Now, let's do the same thing with the second one. And again, I'll use blue to represent the first one. There's 2 x's multiplied together. I'll use green to represent the second one. X to the third really means 3 x's multiplied together. So when I can look at that as a whole now, I have actually 5 x's multiplied together, or x to the 5. All right, let's look at the next one. I have x to the third. So again, I'll represent that with blue. X times x times x. And I have y to the fourth, and I'll represent that in green. I have 4 y's multiplied together. Now if I look, well, this is slightly different. Altogether, I have 3 x's and 4 y's multiplied together, and I can't combine those. So since the bases are different, we basically leave the exponents alone, and we'll say that's x to the third, y to the 4, and that's how we write that one. Now let's look at this last one. Again, I'll represent the first one in blue. I've got 2 x's and 4 y's. 1, 2, 3, 4 y's. And this next one, I have an x. Now, what's the power there? Well, that's really just a 1. It just means there's 1 x there. And we normally, when it's just a single x like that, we normally don't write the power. But think of it as 1. And I have 1, 2, 3 y's. So if I was combining that all together now, I'd have 1, 2, 3 x's multiplied together, and 1, 2, 3, 4, 5, 6, 7 y's. So now we don't want to do this every single time we have a question like this, so the question is there a shortcut? Is there a pattern here? And if we look, we'll see there is. Look at the exponents. When I have 5 and 2, how do I get 7? 2 and 3, how do I get 5? Okay, now this one was different, but 2 and 1 gives me 3, and 4 and 3 gives me 7. We'll see that when we add them, when we multiply these exponents, we add them together, provided the bases are the same. So I say when we multiply monomials, if the bases are the same, we add the exponents together. So we're going to take a shortcut here. When I see this, I just think x is equal to 6 plus 3, x to the 9th power, because there's 6 x's and 3 more x's gives me 9 x's. This will give me x to the 5 plus 7, x to the 12th. Now remember, this is really a 1 here, so this will give me x to the 3 plus 1, which is x to the 4th. And down here, this one, remember we can only add the exponents when the bases are the same. So this will give me x to the 5 plus 4 and y to the 3 plus 7, so x to the 9, y to the 10. All right, and that's the shortcut we're going to take each time. What about when we have a power like this, power of monomials? Well, really what this means is x squared times x squared times x squared. And we know from the last time this would be, we add those exponents together, we get x to the 6th. Well, this one really means x to the 4th times x to the 4th, and we know that we add those together, so that's x to the 8th. This would be x to the 3rd, y to the 4th, x to the 3rd times y to the 4th, because there's 2 of them. So we know when we multiply, we add those exponents again, so it would be x to the 6th, y to the 8th. Now the question is, how do we skip this first step? How do we go from just this to this? And again, what's the connection? What's the connection? How 2 and 3, how do I get 6? Well, we don't add. 4 and 2, how do we get 8? Once again, we don't add. It turns out that we multiply them. So we say that when you raise a monomial to a power, we multiply those powers together. So what do we do here? This will be x to the 6 times 3, or x to the 18. This will be x to the 7 times 3, which is x to the 21. Now here, we're going to have to do both of those, because it's really x to the 5 times 3, y squared to the times 3. So it gives me x to the 15, y to the 6. Okay. Let's look at dividing. What do we do when we're dividing monomials? Well, again, let's go back to the meaning. What does this mean? Well, let me do this one in blue. There's 6 x's on the top, and I'm dividing by 2 x's on the bottom. Now, remember when we're slashing here. This is a fraction again. So 2 of the x's on the top, divide out with 2 of the x's on the bottom. What are we left with? Well, we're left with 1, 2, 3, 4 x's, or x to the 4th. Okay, so what about this next one? Let's do the same thing. Alright, so I'll represent the top in blue. I've got 5 x's, and again, it can be y, it can be whatever variable you want. I'll represent the bottom in blue. In green. So once again, it's a fraction, so we can go ahead and we can be the slasher here. Slash those out, and notice we're left with 3 x's, so we get x to the 3rd. So again, the question is, what's the shortcut? What do we do here? How do we shorten this up? Let's look at this last one. I'll represent the top in blue again, so I've got 3 x's on the top, and in the bottom, I'll represent in green, I've got 4 y's. Now, turns out those don't divide out because they're different. It's just like having a 2 in the top and a 3 in the bottom. They're different. They don't divide out. They have to be exactly the same. So we would just leave this and say we have x to the 3rd, y to the 4th. Now the question is, what's our shortcut here? 6 and 2, how do we get 4? 5 and 2, how do we get 3? And sure enough, we subtract. Now that shouldn't surprise you, because when we were multiplying monomials, we added. It's not surprising when we do the inverse or the opposite operation, we do the opposite operation with the exponents. So it turns out when we multiply monomials, if the bases are the same, we divide them. So again, we don't want you taking the long way each time. We would just say this is x to the 6th minus 3, or x to the 3. 6 x's on the top, 3 on the bottom, they divide out, right? 2 of these x's on the top divide out with 2 on the 2 on the bottom, divide out with 2 on the top, so we end up with x to the 8th. And let's just move this one up a little bit. Get rid of that for me. There we go. I have 12 x's on the top and 5 on the bottom. 5 on the bottom cancel with 5 on the top, leaving me with x to the, well, let me show you. X to the 7. So what about this one? What do I do here? Well, remember I can only subtract like bases. So I think of it this way. Now again, this single x is really an x to the 1. So the 1 on the bottom, divide out with 1 on the top, it leaves me with x to the 5 minus 1, y to the 8 minus 7, so I get x to the 4, y to the 1, or just y, and you can leave it that way. So how are you going to remember that? And that's the big thing. Well, it's easy enough when we do one at a time. What happens when we start combining them? And here's how I encourage students to remember them. Remember our order of operations. And this is going to be true for us here. We start off, we did any operations in the brackets, then we did our exponents next. Then we did multiplication and division in the order that they appeared from left to right. And we did addition and subtraction once again in the order they appeared from left to right. What I tell students is our exponents are more advanced mathematics. It's a step above. Actually, it's a step ahead, is the way I should say it. Because if you're doing an exponent with exponents, they're going to multiply together. If you're doing a multiplication, they're one step ahead. They're going to add. If you're doing a division, they're one step ahead. They're going to subtract. And that's one way that you can try to remember those.